probability continuation topic. So, here ninth question, 6 dice are thrown, the probability that different numbers will turn up. So, we all know that if 2 dice are thrown, total number of outcomes are 6 square, but here 6 dice are thrown, the total number of outcomes are anyway 6 power 6. Now, what is given favorable outcomes we needed is different numbers will turn up. Actually, so these are the digits on each die. So, while single throw, what are the outcomes we get? So, these 6 dice, maybe here we get 1, that 1 won't be repeat in any remaining 5 positions. For suppose this is 3 and 3 won't be repeat here, for suppose is 4, like that. So, all are in different, that means 6 digits can be arranged indirectly, we can think like this, 6 digits can be arranged in 6 different places, that is what is asking, different numbers will turn up. 6 digits can be arranged in 6 different places in how many different ways? 6 factorial ways. So, that is it. Now, your answer is 6 factorial by 6 power 6. Now, that is 6 into okay, just we need to calculate. Will cancel here 2 3 times, now 5 in numerator, 6 into 6 into 36 into 9. Now, that result is 5 divided by 36 into 9, that is 324. So, this is the result. Next question, A and B toss a fair coin each simultaneously 50 times, the probability that both of them will not get tail at the same toss. Okay. So, here I will take one time, for suppose A and B are tossing each one time. If A is tossing, maybe tail will come, if B is tossing, maybe tail will come, head, tail, head. So, these are the maximum possibilities while A and B are tossing each one time. Okay. So, what is given probability? I mean asking the probability that both of them will not get tail at the same time. Total number of outcomes are 4, will not get tail at a time are 3 only. Now, this is the probability while tossing A and B each one time. So, for suppose they are tossing 50 times, second time is also gives the same result, even up to 50 times, that is also gives same result. Now, the product of all those result gives 3 by 4 whole power 50, option A. Understood? Right. Next question, this is important model. You are given a box with 20 cards in it, 10 of these cards have a letter I printed on them and the other 10 have the letter T printed on them. If you pick up 3 cards one by one at random and keep them in the same order, the probability of making the word IIT. What is exactly given question? There is a box, in that 10 I printed, I letter printed on the card are 10. So, 10 letter printed cards are, T letter printed cards are 10. So, these are mixed in this box. So, we need to take out 3 cards one by one, not keeping that cards inside of the box. First letter should be I and next is I and third one is T. So, what is that probability? So, out of 20 letters, the first letter should be I. How many I's are available? 10. Okay. So, out of 10, one I kept here, remaining I letter cards are 9 only. So, total number of letters, total number of cards inside of the box is 19 only. Out of 19, the next card must be I letter card. So, those are 9 only, okay, 9 by 19. So, second I is also kept here, remaining I letter cards are 8 only. Total number of cards inside of the box is now 18. Out of 18, this time we need to select T letter card. So, those are 10. Now, 10 out of 18 is the possibility. So, simplify, this is 2 times 5 by 38. 5 by 38 is the probability of getting IIT, right. Next question, the probability that two integers chosen at random, their product will have the same last digit is. So, this is different question and important also. This is an integer and this is another integer. This is the last digit of the integer. For suppose just we know that this is unit place of the integer. So, while multiplying these two, anyway that result is also an integer. So, what is exactly given question is, per suppose the unit place of this integer is 1 and this is also 1, definitely the resultant integer unit place will be 1. So, this is what is asking, how many such possibilities are there in this condition. So, 1 is one possibility, 0 and 0 another possibility, okay, 5 6 is there, definitely the resultant unit place will be 6. So, these many chances 1 0 0 5 6 these many chances. So, what is the probability? So, actually we just think about these two particular positions only, do not worry about the resultant, that resultant depending on these two particular positions of the integers. Okay, in these two places, in these two different two places can be arranged with 0 to 9. How many different ways we can arrange 0 to 9? 0 to 9 with repetition. So, these all 10 digits can be possible to come in this place, 10 different ways. Here also with repetition is allowed 10. Now, the total number of outcomes are 100. So, very simple, just assume this is 2 digit number, starts with 0 0 ends with 99. How many 2 digit numbers we can make with 0 to 9? Definitely 100 digits, right, 100 numbers. Out of this 100 we need like 1 that is 11, 0 0 that is 0, 5 55, 6 total. How many possibilities out of 0 0 to 99 to come this to satisfy this condition? Only 4 favorable outcomes. Now, that result is 1 by 25, option B. Okay. Next question. So, some correction is there in the given options. This is 12 C3 2 power 9 divided by 3 1 power 12. So, here also 12 C3 2 power 12 divided by 3 power 9 and this is 2 power 9 divided by 3 power 12. These are the options. Okay. Now, the question is the probability that when 12 balls are distributed among 3 boxes, 12 balls are distributed among 3 boxes. These are the boxes, distribute with 12 balls. If the first box will contain 3 balls is, so that is the condition actually. What is total number of outcomes without condition? That means 12 balls can be arranged in 3 boxes. How many different ways we can arrange? 3 power 12. Now, the condition is the first box will contain 3 balls only. Out of 12, first box can be arranged with 3 balls in how many different ways? 12 C3. Okay. So, 12 see 3 ways, we can select 3 balls out of 12. So, 3 is subtracting, now the remaining balls are 9 only. These 9 balls can be arranged in remaining 2 boxes, how many different ways? Not an arrangement, selection, that means. So, total possibilities 2 power 9 ways we can select and make into arrangement into 2 boxes. So, this is the final result. Now, that is option B. Okay. Right. Next question. 7 people seat themselves indiscriminately at a round table. The probability that 2 distinguished persons will be next to each other. 7 people like A, B, C. So, these are can be arranged in a row, definitely 7 factorial ways. For suppose in a circle 7 minus 1 factorial ways. Okay. So, total number of outcomes is 6 factorial. Now, the condition is 2 distinguished persons will be next to each other. For suppose D and E are making as one unit, always these two are in side by side in any arrangement. Now, I just collect number of units 1, 2, 3, 4, this is as one unit, 5, 6. 6 units can be arranged in a circle, 6 minus 1, that is 5 factorial ways. So, these two always come together, but one possibility DE one possibility, ED is one other possibility. So, among themselves can be arranged in 2 different ways. Now, the result is 5 factorial into 2 by 6 factorial can be write into 6 into 5 factorial. Now, answer is 1 by 3, option A. Okay. Right. Next, if 3 vertices of a regular hexagon are chosen at random, then the chance that they form equilateral triangle hexagon 6 points like this. For suppose A, B, C, D, these are the 6 points. If all 6 points are non-collinear, what is meant by collinear? If 3 or more points, minimum 3 or more points are in the same line, then these points we call collinear, but no 3 points are collinear. In that case, if you select any 3 points out of 6, definitely we can make a triangle. So, how many triangles we can make out of 6 non-collinear points? Definitely 6 C3 triangles we can form. Okay. Now, what is the favorable outcome is asking here? Chance that they form equilateral triangle out of all triangles like A, F, B. So, equilateral triangles are only 2. So, these 2 only possible equilateral triangles out of the hexagon. Okay. Now, your answer is 2 by 6 C3, 2 in 6 into 5 divided 5 into 4, 3 into 2 will cancel here, here is 2. So, 1 by 10. So, 1 by 10, option C is the correct answer. Next question, if a leap year selected at random, the chance that it will contain 53 Sundays, leap year 366 days, which is divided by 7, coefficient is 52, that means each day will repeat 52 times. The same question is asking about 52, your probability is definitely 1, that is maximum probability, but we need 53 Sundays. So, all days will repeat definitely 52 times. We need 53rd Sunday, that depending on rest of those 2 days, or rest of 2 days may be Monday, Tuesday, Wednesday, Thursday, okay, Friday, Saturday, Sunday, and Monday. So, total possibilities are 7 chances, but in that favorable chances Saturday, Sunday, Monday, we need 3rd Sunday, 52 Sundays can be possible to get 52 Sundays in a leap year, definitely probability 1, but 53rd Sunday depending on these many chances, that is 2 by 7. Now, answer is 2 by 7. So, this value anyway 1, right. Next. So, that is it. So, actually this is the question number 16. Okay.